Welcome to week 8. We're looking here at question 1, looking at local and absolute extrema. So you may recall from class that we talked about what extrema are in a function and the difference between a local and an absolute extrema. So just to recap, an extrema of a function is any place where the function reaches a maximum level, or at that point we have critical points. And we also note that at extrema that you'll have a slope of 0, so the derivative equals 0. So let me just draw one of the example functions I drew. So here you'll note that we have a maximum here, another peak here, and another peak there. And so we could say that the slope here is 0, slope here is 0, slope here is 0. So that would mean if the slope is equal to 0, the slope is the derivative of the function. So that means the derivative equals 0. We also noted that in order to have a maximum point where the slope is 0, such as here, you see that we have a positive slope on one side of that critical point and a negative slope on the other. Conversely, we see that when there's a minimum point, we have a negative slope that goes then through the critical point at 0. On the other side of that critical point, we have a positive slope. So that's how you're going to identify whether you have a maximum or minimum. Not only are you going to find the critical points, those places where the derivative or slope equals 0, but you're also going to be looking at the landscape around that point. What happens before that critical point and what happens after. And that will help decide whether it's a maximum or minimum point. Okay, so let's have a look at how we work specifically with this question. So let's look at the question and what we're being asked to do. So it says that the number of workers in a certain industry can be approximated by the formula shown below, where x equals 0 corresponds to the year 2000. Okay? Part A asks us to determine in what years the number of workers was at a local maximum or local minimum, and then find the number of workers at those points. Okay? So when we're asked to find the local maximum or minimum, remember we're trying to find that place where the derivative is equal to 0. So the first thing you're going to do is find the derivative of this function. So if we look at what type of function we have, we can see that there's a series of subtractions and an addition. So we're looking at sum and difference rule. We have 4 terms, and each term is either a power term or a constant. So let's start using our power rules. Remember, x to the n, derivative is nx to the n minus 1. I'm going to keep that on the side to remind us. Okay, so here we've got x to the 4th, the first term's derivative, minus 6x cubed minus 72x squared, and then the derivative of 55,000 is just 0 because it's a constant. Okay, so the next thing we have to do, we've taken the derivative, now we set this derivative equal to 0 and solve. Okay. Now this looks a little different from what we may have seen before, but I think if we can factor an x squared out of each of these terms, we may be able to find something that looks a little bit more familiar. So let's do that first. 0 equals x squared times x squared minus 6x minus 72. So now we do have an x squared outside the bracket, but inside the bracket we have a classic polynomial. Okay? So we know that we can find the solution to this x squared minus 6x minus 72. We can either factor or we can use the quadratic formula. Quadratic formula always works. So in this case, we know that if 0 equals x squared times everything in this bracket, we know that either x squared has to equal 0 to make this equation true, or the bracket needs to be equal to 0 in order to make this true. So let's say it's x squared, then x must equal 0. So that's one of the options we have. If we look at this function now, we can factor it. So remember, to factor, I'm looking at two numbers that multiply to give you a product of negative 72. But those same two numbers have to add together to give us negative 6. So I can do sort of a factor tree or something to try and find those two numbers, but I'm going to suggest that they are x minus 12 and x plus 6, right? Negative 12 plus 6 gives us our negative 6, and negative 12 times 6 gives us negative 72. Okay, so we have to say, are these equal to 0? So 0 equals x minus 12, so x must equal 12 in this case. Or x plus 6 equals 0, in which case x is equal to negative 6. Okay? So we have found, through taking the derivative, setting it equal to 0, and solving, that we have three critical numbers. So three places where the function has a slope of 0, and they are at x equals 0, x equals 12, and x equals negative 6. So let's have a look at the next page and we'll see what we do next. So we found that there are three critical points for this function where the derivative or the slope equals 0, and they are negative 6, 0, and plus 12. So the next part of the question asks us to find the number of workers at those points. So we're not working with the derivative anymore. We're going back to the original function, because that is the function that represents the number of workers in that industry, and we're going to substitute each of these values of x into that function. So we've got f at negative 6, and we find that that is a value of 56,684.8. f at 0 is equal to 55,000, and f at 12 is equal to 32,190.4. So we can see by this substitution that we have a maximum when x is negative 6. So that would be in the year 1994, because x is 0 for 2000, 1994. And we have a minimum here when x is 12, so that will be 2000 plus 12, so that's going to be 2012. Okay? So it says in part B, determine the years during which the number of employed workers was increasing and or decreasing. So the next part of the question asks us to determine the years in which the number of employed workers was increasing and decreasing. So if we have a maximum in 1994, we can say that the number of employees was, or employed workers, was increasing before 1994. And we can see then that our numbers of employed workers decreases through 2000, with a further decrease to 2012. So we can say that from 1994 through to 2012, the number of employed workers was decreasing. Part C of the question asks us to determine the absolute max and min, and it gives us a range. So recall that when we're looking at local extrema, we're looking over the whole length of the function, but when we're looking at absolute extrema, we're looking within a certain range. So we need to consider critical points that are within that range, and we also need to consider the end points of the range. So our given range is 1990 to 2010. And we have to remember that x was 0 for 2000. So here we have one end point of x is negative 10 and the other as x is 10. So we can see if we look back up to our critical points, x is 12 is no longer sitting in the range that we're looking for our absolute extrema. Negative 6 is, and 0 is. So now we need to find out which of those critical points has our absolute max and our absolute min. So we should be solving f at negative 10. We should be solving, we already have f at negative 6, we have f at 0, and we have f at positive 10. And we can see that our f at negative 10, if we substitute and solve, is 44,000. And our f at positive 10 is 36,000. So now we need to compare. This f at 12 is no longer within our range, so I'm not considering that anymore. So now we can see that f at positive 10 is our absolute minimum. But we see that negative 6 is still having a greater number of employed workers, 56,684. So negative 6 still remains our absolute max. Okay. Absolute max. And that is how you'd approach this type of question.